Okay, so how do these magic hash functions work? The purpose of a hash function is to transform some value into one that can be stored and retrieved easily. You give it some value, it converts the value based on some formula, and spits out a coded version of the value that's often the index in an array. Let's go through an example to clarify this process. Let's say you're running some big event. Maybe it's for people who like a certain type of music. Everybody who wants to come to the event needs to buy tickets in advance. All of those tickets are randomly numbered, and those numbers are embedded in barcodes on physical tickets that people hand you when they first arrive. You need to be able to look up ticket numbers fast when people check in at the event. Storing the ticket number in one of those incredible hash functions sounds pretty great to you. You have all of your numbers. Now you just need to come up with a hash function to convert them to hash values so they can be stored easily. One common pattern in hash functions is to take the last few digits of a big number, divide it by some consistent number, and using the remainder from that division to find a place to store that number in an array. In this case, the remainder turned directly into the index of an array. Why does this strategy work? Well, if the numbers we had assigned to each ticket were 0 to 100, we could easily store it all in an array and look them up instantly by the index. When numbers are big and random like the ones we started with, we need some way to convert those numbers into array indices quickly. That's how the constant time lookup works. You give your number to a hash function, which spits out a hash code that turns into the index of an array. You can go to your array and get your original value in constant time, since an array lookup with an index happens in constant time. Why use the last few digits of a big number? In most cases, the last few digits are the most random. If you were assigning your numbers in numerical order, the first few digits really wouldn't be random. They're more likely to start with a 1, a 2, a 3, etc. than later numbers like 7, 8, or 9.